We use smartphones while walking, shopping, and cooking. Touch interaction is the primary input method. When done single-handed, there is a risk of dropping the phone and breaking it. A phone ring holder is getting popular as an accessory for smartphones. We put our finger in the ring to hold the smartphone tightly to prevent falling smartphone down from our hands. The concept of this work is to make this phone ring holder a gestural interaction interface. Our interface, RingSense, is attached to the back of the smartphone to extend the mobile interaction space. RingSense consists of 8 pressure sensors, a microcontroller, a natural rubber sheet, a 3D printed case, and a commercially available phone ring holder with a flat plate. The key idea of our RingSense prototype is sensing finger activity on the ring with pressure sensors. When any force is applied to the RingSense, a ring slightly moves because elastic rubber sheets are placed bottom and above the baseplate. Pressure sensors sense those forces. Here we show the signal processing flow. The pressure sensor signals are cut into 1.5-second frames recorded at 100 Hz period for recognition processing. Each value collected from the sensor is normalized to a value between 0 and 1. These values are converted to a grayscale image of size 40 by 30. Using the generated image, the CNN model classifies the finger gesture of RingSense. We conducted 3 studies to design and create the RingSense interface. In the crowdsourced study, we conducted a crowdsourced survey of 300 phone ring holder users to understand existing usage patterns. Results include learning that phone ring holders are typically used with the index or middle finger of the non-dominant. In the first study, we recruited 20 participants for a gesture elicitation study targeting 23 mobile interaction tasks. As a result, we designed 12 gestures for the index finger and 12 gestures for the middle finger, resulting in 24 gestures created. There are 3 types of gestures. The force and tap type gestures that move or tap the finger in the ring. The other is the stroke type gesture where a finger outside of the ring moves along with the ring shape. For the second study, we collected gesture data from 10 participants to train the machine learning model. The results showed a 92.7% accuracy for the gesture classification model, which classifies 12 gestures and 2 fingers in the case of within-user validation. Finally, we present 3 application examples where RingSense is particularly effective. The first scenario is when a user uses a map outdoors. RingSense allows users to easily zoom in, zoom out, and navigate the map application with one hand. This is especially useful when users have bags, umbrellas, or other objects that limit the use of one hand. The second scenario is taking pictures with smartphones. Users can control the zoom level or take a picture shutter with the RingSense. This can reduce the required on-screen interface components. The third scenario is when browsing websites. With RingSense, users can easily browse web pages with one hand without the risk of dropping the smartphone. This is especially useful when users lie down on the sofa or bed. For more details, please refer to the paper.